So trig ratios, okay? So for some review, for others, this will be somewhat new. That it is what it is, okay? So when you're talking trig ratios, right? When do we use it? We use trig ratios, comma, when the question involves angle measures. Okay? When you are provided with an angle and at least one side length, comma, we can use trig ratios to solve for any missing values. It is important to label all three sides of a triangle. Unlike Pythagorean theorem, all three sides have a different name. Sorry. These are opposite, hypotenuse, and adjacent. And I'll tell you how to recognize them. Across the reference angle, right? The opposite is across the reference angle, and I'll talk about the reference angle in a bit. The hypotenuse, this same way as before, that side is going to be across the 90-degree angle. Right? It's going to be across that 90-degree angle. So we call that's the same as before. Nothing changes there. This is the remaining side. It touches the reference angle. Slow down, Mr. Dirksen. Yeah, I will. So go ahead and write this down. Are we following? Or yeah? Okay, I'm not going too fast. So when we do the remote learning, if I go too fast, if one or two or a couple of you can just say, can you hold on a bit? Can you go back? I will not hold that against you, all right? So this is how you recognize where do the sides go, okay? How do I label? Okay, so labeling. Okay, it's important to know how to label. So let's just start with a triangle. So you start from this is our horizontal, we go straight up, and then vertical, and there. There's your 90. This is going to be a this is probably, there are two angles that can vary. This is always a 90 here, but these, right, they will have to give you that. So let's say this is 35 degrees right there. Let's say they give you something like that. If that is the case, I'm going to use different colors here. Blue, red, I got black somewhere. Okay, so different colors are good in this case. So if this is the angle, so keep in mind, degrees, they literally are used to measure the opening between this side and that side, okay? That's 35 degrees. The first thing, the reason I gave you the names opposite, hypotenuse, and adjacent, that I want you to label it in that order. You start with the angle given, you can move out, right? Dun, 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 dun. You hit the side. This is called the opposite side, okay? So we refer to this whole thing as the opposite side. Then you take your 90-degree angle, you move out across from that. Come on, pen, you can do it. There. This is called the hypotenuse. Same as before, right? And the one that's left, right, once you have figured these two out, the other one has to be the adjacent, right? Adjacent side. Okay, so these three sides are always there, right? Always. Let's say I will make a different triangle here. Let's make it upside down to really throw you off, right? So you have that there. And let's say I tell you that this is 42 degrees, like that. And I ask you, okay, label the three sides. Label the three sides, okay? And again, it doesn't really matter the order in which you do this, but I always recommend you doing it in this order. This is the given angle. Move across till you hit the side. This is now your opposite side. Okay? Then across the 90, you move across. This is the hypotenuse. And the last one must be the adjacent. Okay, so that's how you label. If you know how to do that, you're going to be in pretty good shape. Okay, but remember, the hypotenuse never changes, but these two sides do change. How so, Mr. Dirksen? Well, let's say I said, well, how about we work with this angle right here? If I give you this angle over here, now all of a sudden, that is your reference angle. This would be your opposite. Therefore, this would be the adjacent, right? So it always depends on the reference angle. So that's what I'm going to add here. Make an arrow going to that angle. That's the reference angle. That's where you're looking out of. Okay, so you put an arrow there. Reference angle. So it's where the angle is located that determines where the opposite and the adjacent would be. The hypotenuse never changes because the 90 degrees stays where it is. Okay? Okay, so now I'm going to give you the trig ratios. Trig ratios. Okay? What we know is that if we were to take, I will give you a triangle here first. Let's make a triangle like this. Okay, and then let's label it A, B, and C like that. Okay, and remember capital letters are always used for angles and lowercase are used for side lengths. Okay, but if A is our reference angle, right? If A is the one we're looking out of, if that angle, then we would label this as opposite. We would label the one that's across the 90 as hypotenuse. And the last one is your adjacent. Okay. Think of the adjacent as the last kid in the family, right? You've got siblings, you're the youngest, perhaps, maybe you're the oldest, but the youngest is always like, and by the way, yeah, we've got, the youngest of the family. It's not really what it's like, but you feel that way, right? Well, if you've taken care of the opposite, if you're taking care of the hypotenuse, then the adjacent just has to go in there, right? That's the only spot that it can go. So here it is, okay? I will give you the sine, the cosine, and the tan. So first of all, I want to call your attention to your calculator. It should have a sin, cos, tan button. Sine, cosine, and tangent. That's what they're there for. Make sure your calculator is set to degrees. So at the top, somewhere in your calculator, it either says DEG for degrees, or there's a D or something like that. But if it says grad, you're not graduating yet, right? You don't want to be using that. I'm just kidding. But there is something, it's called gradients. That's not the one. You want degrees. If it's rad, like just RAD, you don't want that either. Okay? Make sure it's set to degrees or else you'll be frustrated because your answers are going to be different. This is how you know you're doing this right. Press sine and then 30. Some of you have to go 30 and then press sine. If you don't have a calculator that shows you what you're typing in, you're supposed to get 0.5. If you don't get 0.5, something is wrong. Okay? All right. Let's give this a go. Okay? Okay, so I want you to remember this. So I write it like this. So ka toa. And I know some of you have heard this before. And I write it like that. Okay? What does this have to do with anything? This is just helping you remember that if you're going to be using sine, you need to have the opposite on top and the hypotenuse at the bottom. Cosine requires the adjacent at the top, the hypotenuse at the bottom. Tangent, opposite, and adjacent. Notice that tangent does not have the hypotenuse as part of it. Cosine and tan, they do. So let's write it out. Sine of angle A. Sine always needs an angle attached to it, guys. Do not just put sine down or so in your calculation. I want sine of angle A is going to be the opposite side over the hypotenuse. Always. Those are the two sides that go with sine of A. Okay? Cosine of A would be adjacent, which is in black. That's what I did it with, right? Adjacent over hypotenuse. And tangent of angle A. All these sin, cos, tan always need to have an angle attached to it. It could be a number. In this case, we don't have numbers, so we're using the letter. But you can't just write sine, cosine, tan without an angle attached to it. Remember that. And I don't want to see SOHCAHTOA in your work. That's just to help you remember. So what's TOA? That means that tangent needs opposite side on top and the hypotenuse at the bottom. Like that. Watch this. We're going to take it one step further. So put an equal sign next to all of these. Put an equal sign next to all of them. Then come over here, okay, over this triangle. If this is capital A, what do we call this side here? Lowercase a. C, this would be lowercase c, and this lowercase b. Okay? So now let's do the same thing that we've been doing here, but just using letters. Okay? Opposite is A, right? And hypotenuse is B. Cosine is adjacent, which is side C over B, which is the hypotenuse. Tangent is opposite over adjacent. They're all saying the exact same thing, except for here, right? We actually use the actual like labeling of the triangle. Oh, yes. Oh my goodness. I need to use whiteout, guys. My apologies. Do you notice what I did wrong? TOA is supposed to be opposite over adjacent. Can you please change that? Thank you, Francis. I was looking at my time and I'm rushing here. Don't rush. That's the moral of the story. Okay. We're kind of going to go right till the end, guys, okay? So my apologies. Jason, there. Thank you, Francis. Okay. Please put this on your study sheet. This thing right here, I'm going to box that in. Okay? This should be in your study sheet. If you've paid attention to anything I've been doing, anything that's boxed in is kind of important, right? Okay. I think I'm just gonna do, I'm not gonna do solving today. Here, copy this quickly. Dun, dun, dun. We're gonna go D, E, F. Okay? And we're gonna go 5, 3, and 4. By the way, if you ever hear the word like a 3, 4, 5 triangle, a 3, 4, 5 triangle, you're guaranteed that it's going to be a 90-degree angle. Okay? That's what the Egyptians used to make the pyramids. Okay. here, I'm gonna see if you understand what's happening. Sine of D is equal. Cosine of D is equal. Tangent of D is equal. Put a line, and then we're gonna go sine of F is equal. Sine of D is cosine of F is equal, and tangent of F is equal. Line, line, line. We're gonna finish this before you go, okay? So don't hang up, okay? It's very important you get this right. Always have SOHCAHTOA ready to go, because that's gonna help you remember which two sides go here. If we're looking at D, this is all looking at D, right? That's our reference angle here. Let's make a little note here. That means that this is opposite. This is the hypotenuse. And this is the adjacent, right? So sine of angle D is opposite over hypotenuse. That means we need to put the 3 up top, the hypotenuse down here. Got it? Does that make sense? Opposite. Cosine is supposed to be adjacent over hypotenuse. So the adjacent is 4, hypotenuse is 5. All you're doing is just grabbing the numbers and putting them where they're supposed to be. Tangent is supposed to be opposite over adjacent. So that's opposite over adjacent. Next, this is where it's going to get a little confusing. Maybe. Not if you really understand what's happening. What's our reference angle here, folks? It's angle F. So now you got to position yourself here. What's this side called now? Folks that are in class, what's this side called now that my reference angle? Opposite. So you scratch that, you make this opposite. So what will this be? This will have to be adjacent, right? There's no other way. So now let's think about it again. Sine is opposite over hypotenuse. So what's opposite here? It's 4. Hypotenuse never changed, right? Cosine is adjacent, which is 3, over hypotenuse, which is 5. Tangent is opposite. This helps you. This helps you. Is opposite over adjacent, which is 3. And there you have it, right? You've labeled them all. Now, we're going to leave it at that. Tomorrow I will give you some worksheets to work on this, and we're also going to solve. So this is it for today. Hang up. Have a good one. See you tomorrow, okay?